So where possible, I like to break down projects into subsections. It makes it a lot easier to manage. For example, if I was working on a table, I'd work on the tabletop and then the base, or vice versa, rather than sort of intermixing it. It makes it a lot easier to keep track of deliberate grain choices so that I'm not getting pieces mixed up. In this case, it's going to be no different. I'm going to work on the side section first. So the side section will consist of 2 legs, 2 stretchers and a panel. Nothing particularly fancy. There will be 4 of these side sections because I'm working on 2 of these side tables. So the only things to note here for the grain selection would be the legs will be rift sawn. That is, the direction of the grain is going to be going diagonal across the piece. This way the grain pattern will be the same on all 4 sides, and for the stretchers they'll probably be quarter sawn. Undecided on the panel yet, but the legs and stretchers come first. So these need to be jointed, ribbed, thicknessed, all of that. But because this is a pretty long piece and I've got spaghetti arms, I need to break this down first into sections. Those pieces are now square, one side, one face, and I can rip things down to a rough width. In this case, it's going to be 40 millimeters or a little bit over 1.5 inches. These pieces should yield 2 legs, and then there'll be some waste on the side. Now that's where I've positioned a lot of the ugly parts of this board. If you've got a better quality board than this, you could certainly get 3 pieces out of it. There's a couple of ways you could cut this down into the closer to actual dimension stock. One would be using the bandsaw. It's a great way to rip a whole bunch of material, but as you've probably guessed, I'm over here at the table saw, so that's the method I'm going to use. The motor in my saw is a 1 3/4 horsepower motor, so it's fine for 99% of stuff and even just occasional heavier duty ripping using my standard 40 tooth blade, but I've got 8 legs to make up, so I'm going to switch to a coarser heavy duty rip blade. If this was softwood, like softwood pine, it could probably be fine, or if it was not quite as thick. This Vig Ash isn't the hardest wood by Australian standards, but it's harder than most American domestic woods, so just that little bit of extra grunt means the motor's not straining as much and there should be less cleanup. That being said, this blade does leave a rough surface, so you need to account for that if this is the method you're going for. So instead of aiming for 40 millimeters, I'm going to aim for about 41, 42 millimeters, and that just gives me a little bit of room to clean up at the thickness of it. The legs are squared off at one end of the miter saw, then flipped and adjusted to the final length. This ensures both ends are actually square. The lower rails are 70 millimeters and I don't have any material anywhere close to that, so the only way to achieve that without lamination is resawing. The bonus from this is that I will maintain the rift sawn grain. After cleaning up at the thicknesser, the rails can be ripped to final width, 40 and 70 millimeters depending on whether they're upper or lower rails. Everything can be cut to final length using the same process as the legs, squaring one end then cutting to length, except this time as at the table saw using a crosscut sled. All of those parts are cut. I've got my small aprons, my long aprons, my tall short aprons and my tall long aprons, and all of my legs, and boy does it look like a lot of parts when you've got 2 sets of drawers sitting on your workbench. The legs still need their taper cut into them. The short lower and long lower aprons all need a curve cut into them, and all the aprons need a groove cut in for the panels. However, I'm not going to do that yet. I'm going to put in all the joinery first. The way I like to do it is, while everything's still nice and square, it's a lot easier to reference off a stop or a sled or whatever while it's still square, so this is the best time to cut joinery. Speaking of joinery, I will be using the Festool domino. I'll be using 8mm dominoes for the whole project. I've got the tool here, it makes a lot of sense for me. However, I do understand not everyone has that, so I have 2 videos in particular that would be more than appropriate for this. The first is using a plunge router and the table saw to do mortise and tenon joinery, and that would be using a crosscut sled or miter gauge to cut the tenons and a plunge router to cut all the mortises. The second video is loose tenon joinery with just a router, and that would be perfect for this application. If you are going to use the domino for something like this, this is a great attachment. It's got 2 moving fences and slides onto the front of the machine. Those moving fences are fantastic when you're doing a lot of very repetitive cuts where you don't need to lay out every single one of them. So how this works is once it's attached to the domino, you mark out one workpiece, mark your center line in this case, and I can adjust these 2 outside fences so that this just slips onto my apron. Then all the other exact same aprons will have all the exact same settings, so it becomes a lot faster. I don't need to actually mark out or line up the center point because it's already set. Regardless of what tool you're using for making the mortises, there are some consistent issues you're going to run into with this type of design in terms of layout. So the thing to remember is that while a pair of legs is then mirrored, and that's the 2 sides, none of the legs are the same, they aren't symmetrical, particularly once the tapers are added in. I like to mark out at the top of my legs all the different orientations so that I know where each leg goes before I even start cutting the joinery. For example, I've got right front in front of me, I've got left back, left front, right back. I've also got where the mortises should roughly fall. It's not measured out, it's just marking which side actually should receive the mortise. In this case, this is the mortise for the top long rail. So I have a line indicating the halfway point of the rail. Let's see there. That's the center point of my mortise. And this little arrow here points to where I actually need to line up my tool. Now, if you're using a router, you'd do this a little bit differently. But for the domino, I know that the cutter needs to come in from this side, hence where the arrow is pointing towards where the domino would be. For additional making sure that I've got the right side, you can see that I've got these brown stickers on it. So in the case of this right front leg, the mortises on these 2 faces are going to be in the same position and the same offset. It's going to be a 10mm offset. I'll need to check my plans, might be 5mm. And they're in the exact same positions. However, the right back, for example, the short side will receive 10mm in for its mortise, but on the back side that will be flush. So instead of having a 10mm reveal, it'll be flush like so. A test cut to establish the proper position is performed on one of the cut-offs from the rail. I'm aiming for a target of 5mm offset from the face. Once the correct position is found, the actual cut can be made in the rails. This is done in 2 passes. It's a 1/4 inch bit and I find it easier to control when performing about half the diameter in depth per pass. The final height is set referencing the closest 5mm thing I have on hand, which happens to be a domino. The actual height isn't all that important, so long as it's about 4 to 7mm. For the panel, the legs and the upper and lower short rails receive a groove. This will allow the panel to float in it. And it's a little bit easier to do the short rails at the router table and the legs using a plunge router. You could use a table saw and dado stack to make the groove in the short rail, as it is a through groove. And you could conceivably use the router table to make the groove in the legs. However, as I've mentioned in previous videos, I just don't enjoy doing plunge cuts at the router table, so the larger size is just easier to do with a plunge router, I feel. And the reason for cutting the rails first is I can use those exact placements of the groove to mark out where it'll go on the leg. It doesn't really matter if the offsets are 5 millimeters and 5.5 or 6.5, so long as they're consistent throughout the whole piece. So if one leg groove was off a little bit, it would look a bit dumb. But if they're all consistently off, that's more important than being exactly 5 millimeters. As you can see here, for a little bit of extra balance, I've got a second leg clamped in as well. This just means it's less likely to tip. We're going to make a sample cut just to make sure everything does line up. And once it does, I can then route all of the grooves on all of the legs. The panels were glued up oversized so that they could be thicknessed down to a perfect snug fit. The construction and usage of the drawing bow was covered in a previous episode. Alternatively, you can always print the curve onto paper and stick that onto the plywood template. The curve comes up 15mm in the middle for both the long and short rails, which creates two different radius arcs. The template is cleaned up using both a spindle sander and a flexible backed hand sander. This is why you want to use a thin plywood or MDF for your templates. The template and workpiece are loaded onto my template routing sled. This sled is just a piece of plywood, an adjustable fence to reference the template and workpiece up against, then a couple of match fit clamps. The template matches up with the length of the rail, so it's easy to align on the ends by feel. Alternatively, double-sided tape to attach the templates will work too. Remember to route downhill only. This means routing halfway, stopping and flipping the workpiece and continuing the routing. Otherwise, you may be faced with some pretty extreme chip out. Apart from all of the joinery being easier to cut when everything is nice and square, there's also a reason for doing it in a particular order. Cutting the joinery first let me attach the aprons, then I could cut the curves of the aprons, then using those aprons I know where my tapers are going to start because each of the legs is going to receive two tapers on their inside faces. The inside faces as in facing towards the inside of the cabinet rather than the outside. The legs will go down from 40mm down to 30mm, and that angle works out something like 5.71 degrees. It's not an important angle. The important thing is just that they meet up at those 2 points. The easiest way I've found to make tapers is using a tapering sled at the table saw. I have a link to this one, but it's basically the match fit one. However, grab a sheet of plywood and screw down a couple of reference blocks and maybe a toggle clamp, and it's easy enough to make a very quick tapering jig. It's just that I've used this a few times now, so it makes more sense to have it adjustable rather than making a new jig for every single angle. Of course, you could use a bandsaw to make these tapers, just freehanding it and then cleaning it up using a hand plane. But this is just as quick, if not quicker, and requires less cleanup. I will need to do some sanding on the edges, but it's really not a big deal. And even getting those exact marks between 40 and 30 millimeters isn't all that important so long as it's consistent between all of them. The initial setup was really quite easy. I have a line where I want to start, and on the end grain I've got a line where I want it to end, so I just line that up with the edge of the board, which is in line with the kerf of the saw, or the teeth of the saw, so that I know that it's essentially a zero clearance there. Then setting my stops means that when I move on to the next piece, all I have to do is butt it into the stop and clamp it down. An easy thing to check is that there will always be joinery on the face that's being cut away, as those are the inside corners at this stage of the project. This is as good a point to wrap up as any. We've got the side frames pretty much all done now, and yes, there are the long rails on the front and back, but they are identical to all the other rails minus the dado for the panels. At this point we can see a lot of the details really starting to come together, and it does actually look like it is meant to in the rendering, so that's very nice. The subtle details of the curves and the tapers, as well as the consistent offsets, makes it look nice, at least to my eye. Now this is just dry fit together at this stage. It is not glued because there's still a little bit more work to do on the legs, but they will rely on the web frames, which the web frames and the tops will be the subject of the next video. Thanks for watching.